Okay, we can continue with the previous day section. First of all, Python is created in the year 1989. It is actually a very easy programming language. Nowadays, it is a very famous one. And one of the reasons is a lot of people prefer Python because it is very easy to understand, very easy to grasp this language. So Python is an interpreted, object-oriented, high-level programming language, and it can be very easily implemented. Now, let me tell you some of the features of Python. Okay. Very simple thing is, it is easy to learn. It is one of the easiest programming language. And also, it is also free and open source. Apart from this, it is a high-level language. You don't have to worry about anything like memory allocation. It is portable, that is meaning that is you can use it in any platform like Linux, Windows, Solaris, and so on. It supports a different programming paradigm like object-oriented and procedure-oriented programming. And it is a extensible, meaning that is, it invokes in C and C++ libraries. Apart from this, let me tell you that Python is actually gaining unbelievable, huge momentum in AI. The language is used to develop data science algorithms, machine learning algorithms, and IoT projects. The other advantage to Python, it is also the fact that you have not to code much, not needed to code much more. When it comes to Python for AI or machine learning, there are predefined packages that have a lot of functions and algorithms stored. For example, there is something known as Pygame, NumPy, which can be used for scientific computations, pandas, and so on. There are n number of libraries in Python. So we prefer a Python a lot. Next, introduction to machine learning. Many of them are thinking machine learning and AI are same thing. Well, both of the term are not same thing. Machine learning through which you can feed a lot of data to the machine and make it there. Now, AI is a vast field. Under AI, we have machine learning, we have NLP, we have image recognition, object detection, and so on. So AI is sort of a process, or it's a methodology in which you make machines mimic the behavior of human being. Machine learning is a way in which you feed a lot of data to the machines so that it can make its own decisions. Let's get into depth about the machine learning. So first, we will understand the need of machine learning. So why machine learning come into existence? Now, the need of machine learning begins since the technical revolutions itself. 1 minute. So guys, since technology became the center of everything, we have been generated an immeasurable amount of data. As per research, 1 minute. Sir?
Yes, madam.
Okay, shall I?
Yes, yes, yes.
Yes, okay. Um, okay, so as per research, we generate around 2.5 quintillion bytes of data. Every single data, every single day it's happened. And it is estimated that the year to 2020, 1.7 megabytes of data will be created every second for every person on earth. It's generating a lot of data. Now, most of them today, they are watching on YouTube, right? So all the accounts for data generation, there is a data everywhere. So with the availability of so much data, it is finally possible to build predictive models that can study and analyze the complex data to find the useful insights and deliver more accurate results. So, on the top tier companies like Netflix and Amazon, which build such machine learning models by using tons of data in order to identify any profitable opportunity and avoid any unwanted risk. So, guys, one thing you all need to know that the very most important thing for artificial intelligence is data. For artificial intelligence, or whether it's machine learning or deep learning, it always data is wanted. And now that we have a lot of data, we can find the way to analyze, process, and draw useful insights from this data. In order to help us grow business or to find a solution to some problems, data is the solution. We just need to handle the data, and the way to handle the data is through machine learning, deep learning, and artificial intelligence. There is a few reasons why machine learning is so important. Next slide. As a number one is due to increase of data generation. Data generation is very much important. So due to excessive production of data, we need to find a method that can be used to structure, analyze, and draw useful insights from data. This is where machine learning comes in. So it is used to solve problems and find solutions through the most complex tasks faced by organizations. Apart from this, we also needed to improve decision making. So by making use of various algorithms, machine learning can be used to make better business decisions. For example, machine learning is focused on sales and it is used to predict any downfalls in the stock market, and it is used to identify the sort of risk anomalies or to identify any sort of risk and anomalies. This was happened with the help of AI. Other reason includes machine learning, which helps to uncover patterns and trends in data. So finding hidden patterns and extracting key insights for data is the most important part of machine learning. So by building predictive models, that is using a statistical techniques, machine learning allows you to the depth, to go for the depth of the surface, and it's explore the data at a minute scale. Understanding data and extracting patterns manually takes a lot of time. it will take several days for us to extract any useful information from data. But if we use machine learning algorithms, we can perform similar computations in less than a second. Another reason is we need to solve complex problems. So from detecting the genuine links to the deadly ALS disease to building self-driving cars, machine learning can be used to solve most complex problems. At present, we also found a way to spot stars, which are 2,400 light years away from our planet. Okay, all of this is possible only through AI. Machine learning, deep learning, and these techniques. Machine learning is a very important at present because we are facing a lot of issues with data. We are generating a lot of data. We have to handle this in such a way that is a benefits and why we are going for machine learning like that. And now, more to what exactly. So let me give you a short history of machine learning. So machine learning was first coined by Arthur Samuel. When artificial intelligence was coined, so looking back to that year was probably the most significant in terms of technological advancement because most of the technology today are based on the concept of machine learning. And most of the AI technologies that itself are based on the concept of machine learning and deep learning. That don't confuse about the machine learning and deep learning. In the further slides, we will discuss about all those things and we will see the difference between AI, machine learning, and deep learning. So coming back to that, what exactly machine learning is? If you browse through the internet, you will find a lot of definitions about what exactly machine learning is, right? So one of the definition I found in the computer program is that to learn from experience E with respect to some class of task T and performance measure P, it's a performance of task in T as measured by P, which improves the experience E. Like this way I learn. That was very confusing. So let me just narrow it down to you. In simple terms, machine learning is a subset of artificial intelligence. Which provides the machines the ability to learn automatically and improve with experience without being explicitly performed to do so, right? So in this sense, it is a practice of getting machines to solve problems by gaining ability to think. But now you might be thinking, how can a machine think or machine take the decisions? Now the machines are very similar to humans. Okay, if you feed a machine a good amount of data, it will learn how to interpret, process, and analyze this data by using machine learning algorithms. And it will help you to solve world problems. So what happens? There is a lot of data is fed to the machine. The machine will train on this data and it will build a predictive model. With the help of machine learning algorithms, in order to predict some outcomes or in order to find some solution to the problem. So it involves data. You are going to train the machine and you want to build a model by using a machine learning algorithms. In order to predict some outcomes or to find a solution to the problem, so that it is a simple way of understanding what exactly the machine learning is. Let me see some that is a machine learning definitions. Now let's discuss a couple of terms which are frequently used in machine learning. So the first definition that we come across very often is the algorithm. So basically, a machine learning algorithm is a set of rules and statistical techniques. It is used to learn patterns from data and draw a significant information from it. So significant information we can get from this machine learning. So guys, the logic behind a machine learning model is basically a machine learning algorithm. Okay, an example of the machine learning algorithm is linear regression or decision tree or a random forest. All of these are machine learning algorithms. We will define a logic behind a machine learning model. Now, what is machine learning model? A model is actually a main component of the machine learning process. Okay, so a model is trained by using a machine learning algorithms. The difference between an algorithm and a model is that an algorithm maps all the decisions that a model is supposed to take based on the given input. In order to get the correct output, so the model will use the machine learning algorithms. In order to draw useful insights from the input and give you an outcome that is a very precise. That's a machine learning model. The next definition we have is predictor variable. Now, a predictor variable is any feature of the data that can be used to predict the output. Okay, let me give you an example to make you understand the predictor variable is. Let's say you are trying to predict a height of the person depending on the height of the weight. So here, your predictor variable becomes your weight because you are using a weight of the person, right? So to predict the person's height. So your predictor variable becomes your weight. The next definition is response variable. Now, as the same example, the height would be the response variable. The response variable is also known as the target variable or the output variable. This is a variable that you are trying to predict by using the predictor variable. So a response variable is a feature or the output variable that needs to be predicted by using predictor variable. Next, we have something known as a training data. The training is very much important. So now the training and testing data are the terminology that you will come across very often in machine learning process. So training data is basically a data that is used to create a machine learning model. Basically, in machine learning process, when you feed a data into the machine, you will be divided into two parts. So splitting the data into two parts is known as a data splicing. So you will take over your input data. You will divide it into two sections. One you will call the training data, and the other you will call the testing data. Training and testing is very important. So then you have something known as a testing. The training data is basically used to create the machine learning model. The training data helps the model to identify key trends, patterns, and essential, that is to predict the output. Now, the testing data is after the model is trained. It must be tested in order to evaluate how accurately it can predict an outcome. Now, this is done by using a testing data. So basically, the training data is used to train the model and the efficiency of the model. Now, let's move on to get to the next topic, that is a machine learning process. So what is machine learning process? Now, the machine learning process involves building a predictive model that can be used to find a solution for the problem statement. Now, in order to solve any problem in machine learning, there are a couple of steps that you need to follow. Let's look at the steps. The first step is you define the objectives of the problem. Next, data generating, that is the data gathering, which is followed by preparing your data, data exploration, building a model, model evaluation, and finally making predictions. Actually, let's assume that you have been given a problem that needs to be solved by using machine learning. So the problem is that you need to solve is we need to predict the occurrence of the rain in your local area. That is, predict the occurrence of rain in your local area by using machine learning. So basically, you need to predict the possibility of rain by studying the weather condition. So what we did here is basically looked at step number 1, which is define the objective of the problem. Now, here you need to answer the questions, such as that is what we are trying to predict. Is that output going to be a continuous variable, or is it going to be a discrete variable? These are the kinds of questions that you need to answer in the first page, which is defining the objectives of the problem, right? So yeah, it is exactly what your target feature. So here you need to understand which is your target variable and what are the different predictor variables that you need in order to predict the outcome. So here a target variable will be basically a variable that can tell us whether it's going to rain or not. Our target is we want to find that one, right? So here a target variable will be, first we are giving the input data. Well, we will need the data such as it may be a temperature on the particular day or the humidity level, the predictions and so on. So you need to define the objectives on this stage. So basically you have to form an idea to this problem at this storage. Another question that you need to ask yourself, that is, what kind of problem are you solving? Is this a binary classification problem, or is this a clustering problem, or this is a regression problem? Now, a lot of you might not be familiar with the terms of classification, clustering, and regression in terms of machine learning. All you need to understand at step 1 is you need to define how you're going to solve these problems. You need to understand what sort of data you need to solve the problem, how you're going to approach this problem, what are you trying to predict, what variable you will need in order to predict the outcome, and so on. Let's move on and look at the step number 2, that is data gathering. Now, in this stage, you must be asking questions such as what kind of data is needed to solve the problem? And is this data is available? And if it is available, from where I can get these data? And how I can get the data? All those questions you want to ask. The data gathering is one of the most time-consuming steps in machine learning process. If you have to go manually and collect the data, it's going to take a lot of time, right? It's true. But we are lucky for us that we are having a lot of resources in online, which were wide data sets. All you need to do, can grab by using websites itself, online itself, we can download the data, where you just have to go ahead and download the data. One of the websites I can tell you that all, I think so that about the Kaggle. So if you're a beginner in machine learning, don't worry about the data gathering and all of that. All you have to do is go to that website such as Kaggle, you can browse it and just download the data set. You can give the topics which related to which topic you need the data set. You can search it based on that. There will be so many links will be there, which is convenient to your project like that. You can download it and you can easily use it. So coming back to this problem that we are discussing, which is predicting the weather, the data needed for weather forecasting, which includes measures like humidity level, the temperature, the pressure, the locality, whether or not you live in the hill station. Such data can be collected and stored for analysis. So all the data is collected. During the data gathering stage, this step is followed by data preparations and also for data cleaning. So the step 3 is preparing the data. So if you are going around collecting data, it's almost never in the right format. And even if you are taking the data from online resources and from any website, even then the data require cleaning and preparation. That is important one. The data is never in the right format if you have to do some sort of preparations and some sort of cleaning in order to make the data ready for analysis. So you will encounter while cleaning data is a lot of inconsistency in the data set. Like you will encounter some missing values and redundant variables, duplicate values, and all of that will be present. So we want to remove it, we want to clean it. That's why we are going for this preparing data. Data is collected, then we are going for this cleaning process. So removing such inconsistencies is very important because they might lead to any wrongful computations and predictions. Okay, so at this stage, you can scan the data set for any inconsistency and you can fix them. Then fix it and you can do it. Now, let me give you a small fact about the data cleaning. So there was a survey that was run last year. I think so. I'm not sure about that. And a lot of data scientists were asked which step was the most difficult or most annoying and time consuming of all. And 80% of the data scientists said the data cleaning. It has a very difficult task as data cleaning. Data cleaning takes up to 80% of their time. 100% for doing any projects and all. So 80% we are taking for data cleaning, remaining 20 for all those things, right? So it's not very easy to get rid of missing values and corrupted data. And even if you get rid of missing values, sometimes your data set might get affected. It might get biased because maybe one variable has too many missing values. One variable can have the too many missing values. And this will affect our outcomes, right? So you will take how to fix such issue. You will have to deal with all of the missing data and corrupted data. So the data cleaning is actually one of the hardest steps in machine learning. So, okay, let's move on to look at the next step. Data cleaning is done. Next, which is exploratory data analysis. So here, what you do is basically, that is a stage, which is exploratory data analysis is like a brainstorming stage of machine learning. That is like a brainstorming stage. Data exploration involves understanding the patterns and the trends in your data. So at this stage, all the useful insights are drawn and any correlations between the various variables are understood. What you want to do, that means by trends, that is a patterns and correlations. Now let's consider an example, which is we have to predict the rainfall on the particular day. So we know that there is a strong possibility of rain if the temperature has fallen down. So right, so we know that our output will depend on variables such as temperature, humidity, and so on. Now, to what level it depends on these variables. We will have to find out that we'll have to find out the patterns and we will find out the correlations between such variables. So such patterns and trends have to be understood and mapped at this stage. So this is what exploratory data analysis is about. It's the most important part of machine learning. This is where you will understood what exactly your data is and how we can form the solution to your problem. Next step is a machine learning process, is building a machine learning module. So all the insights during the data exploration are used to build a machine learning model. So this stage always begins by splitting the data set into two parts, which is training data and testing data. That the data that you use in machine learning process is always will be split into, right, two parts, training and testing, that already you know. Some of the peoples, they know, some they are in the starting stage. So now you're building a model, you always use the training data. So you always make use of the training data in order to build a model. Now, a lot of you might be asking, what is training data? It is different from the input data. That's you're feeding with the machine, or it is different from the testing data. Now, the training data is the same input data that you're feeding to the machine. The only difference is you are splitting the data set into two. You are randomly picking 80% of your data and you are assigning for training purpose. And the rest, 20% probably, you will assign in the testing purpose. 80% for training purpose. Randomly, you can take the data from the data set. 20% will be for testing purpose. So guys, always remember another thing, that is the training data is always much more than your testing data. Obviously, that is because you need to train your machines, then only you can get the result, right? So all the more data will be fed to the machine during the training phase. The better it will during in the testing phase. Obviously, it will predict better outcomes if it is being trained on more data. Why we are giving that 80% of data for training means if you train very well, you can easily get the result, right? So the model is basically using the machine learning algorithms that predicts the output by using the data feed to it. Now, in the case of predicting rainfall, the output will be categorical variable because you will be predicting whether it's going to rain or not. Okay, so let's say we have an output variable called rain. The two possible values that variable can take is going to rain or no. First one is yes, it's going to rain, or no, it won't rain. That is a two variable we are going to possible values or that. So correct. So that is outcome. Our outcome is classification or the categorical variable. Such cases where your outcome is a categorical variable. You will be using classification algorithms. Again, same example of the classification algorithm is logistic regression, or you can also support vector machines. You can use a k nearest neighbor. You can also use a naive Bayes and so on. So many algorithms are present. Now, don't worry about these terms. All those algorithms we can discuss later. But just remember that while you're building a machine learning model, make use of the training data. You will train the model by using all the training data and the machine learning algorithm. You are training the data with the help of machine learning algorithms. Now, like I said, the choosing the machine learning algorithms, which depends on this problem statement that you are trying to solve. Because there is a n number of machine learning algorithms are there. We'll have to choose the algorithm that is more suitable for your problem. So step number 6 is model evaluation and optimization. Now, after you have done building a model by using a training data set, It's finally time to put the model test. The testing data set is used to check the efficiency of the model and how accurately it can predict the outcome. So once the accuracy is calculated, any further improvements in that model can be implemented during that stage. The various methods that can help you that improve the performance of the model, like you can use a parameter tuning and cross validation method in order to improve the performance of the model. Now, the main thing you need to remember during this model is evaluation and optimization. Is that the model evaluation is nothing but you are testing how well your model can predict the outcome. So at this stage, you will be using the testing data set. In the previous stage, which is a building a model, you will use a training data set. But for using a model evaluation, you want to use the testing data set. Now, once you tested your models, you need to calculate how accurately your model is predicting the outcomes of. After that, if you find that you need to improve your model in some ways or some other way, methods, because accuracy is not very good, then you will use a method such as a parameter tuning. If your accuracy is not that much good, you can go for next model and next methodology, next algorithm also you can choose it and go for a training and testing will be done once again. So don't worry about these terms. And but I'm just trying to make sure that you are understanding the concept behind each of the phase and machine learning. It's a very important you to understand each step. Because with the help of all those things, we are doing the testing and training. The last stage of machine learning, which is predictions. Now, once a model which is evaluated, and once you are improved it is finally used to make predictions. The final outcome can be either be a categorical variable or a continuous variable. Now, all of this, which is depends on your problem statement. That is, don't get confused about this continuous variable and categorical variables. Now, in our case, because we are predicting the occurrence of rainfall, the output will be categorical variable. It's because we're predicting whether it's going to rain or not. The result we understand that this is a classification problem because we have a categorical variable. So that we use the entire machine learning process. Now it's time to learn about the different ways and look at the types of machine learning. Now, this is one of the most interesting concepts in machine learning. The three different ways in which machine learning learn. There is something known as supervised learning, unsupervised learning, and reinforcement learning. We can go through one by one, can understand what learning is first, and then we can took over to the two types. So define supervised learning. It's basically a technique in which we teach or train a machine by using a data which is well labeled. The labeling is very important in supervised learning. So in order to understand the supervised learning, let's consider a small example. There is a kids they needed to give the guidelines to solve any mathematical problems. Like a lot of us had the trouble of solving maths problems. So our teacher always help us to understand what is addition and how to do it, right? That is a teacher's work, they will do it. Similarly, you think of supervised learning as a type of mission that involves to guide the label data set. The label data set is a teacher. Let me take they are a teacher. That will train you to understand the patterns in the data. So the label data set is nothing but a training data set. So it's understand the supervised learning better, I think so. Let's look at the figure on the screen. Right here, we are feeding to the machine that all those figures, that images of Tom, Jerry, and the goal is for the machine wants to classify into two classes. One will contain the images of Tom and other will contain the images of Jerry. Now, the main thing is that you need to note in supervised learning is a training data set. The training data set is going to be very well labeled. Now, what you do is, that you want to say that as a training data set label, that is very important thing. Basically, what is doing is where telling the mission. It will tell the missions what we are going to do and how the Tom looks and how the Jerry looks. By doing this, you are training the machine by using the label data. We are giving the label. This is a Tom, this is a Jerry, like that. Then only it will be trained. So main thing that you're doing is you're labeling. Every input data you're feeding to the model wants to be labeled. And basically your entire training data set is labeled. Whenever you're giving an image to Tom, that is going to be labeled that's saying this is Tom. And whenever you're giving the image of Jerry, it wants to say how Jerry looks. This is Jerry. So we are guiding the machine. You are telling that, listen, how this is how Tom looks and how Jerry looks. And now you need to classify them into two different classes. That's how supervised learning works. Apart from that, it's a same old process. After getting the input data, you're going to perform the data cleaning. Previously, I teach, that is for data cleaning and then exploratory data analysis, which is followed by creating the model by using a machine learning algorithms. And then this is followed by model evaluation and finally your prediction. Now, one more thing is you want to note here is the output that you get by using supervised learning is also labeled output. Input also I am giving by using a labeled method and output also I can get with the labeled output. So basically you will get two different classes of name, Tom and one of the name is Jerry. And you will be get named, that is how supervised learning works. The most important thing in supervised learning is you are training the model with the help of labeled data set. Right? So let's move on to the unsupervised learning. Unsupervised learning. It involves a training by using an unlabeled model. Here you can see previously we have given the label, everything we have given the label. But here we are not giving a label. This involves the training, that is, this follows the information without any guidelines. Previously, I said, like a teacher, the label is giving and it is giving the guidelines. But here, no guideline is given. The name, like the name suggests itself, there is no supervised, that is unsupervised. Right? So think of unsupervised learning, a smart kid that learns without any guidelines. Previously, I said the kid is there, teacher is teaching, giving the guidelines. Like this way, the Tom will be there. This way, the Jerry will be there. Like this way, you finally want to classify it. Like that, the teacher giving the guidelines. Right? That is a supervised learning. But unsupervised learning is a smart kid, genius kid. Without the guidelines, the kid that learns itself, that comes under that unsupervised learning. Right? So, okay, in this type of machine learning, the model is not feed any label data to this model. It not gives any clues also. It figures out patterns and difference between the Tom and Jerry. It owns by taking a tons and tons of data. How do you think the machine identifies this is Tom and finally gives output, this is Tom, this is Jerry, like that? So automatically it's trained and automatically it giving the values of giving the results of. So what an unsupervised learnings or the model, does it form two different clusters? Before that, we have gone for classification, separated, right? Here, clustering algorithm they are using. It will form one cluster which is very similar and another cluster which is very difficult from the first cluster, which is different from the first cluster. That's like that it is forming, which is and all same related to that will be formed as a one cluster, and another will be remaining. All those things comes under next clusters. The machine has to understand the pattern, and then it discovers the output of its own, and finally the machine will form the clusters based on the feature similarities, features, right? So based on the feature, it can take the similarities and you can find it out, all those things. So this is a last type of machine learning, that is sorry, reinforcement learning. This is a quite different. Reinforcement learning, it's a part of machine learning where an agent is put in environment and learns. Sorry. Where an agent is put into the environment and learn to behave in that environment by performing certain actions and observing the rewards which gets based on the action. That comes under reinforcement. So shall I conclude up to this? Tomorrow I can start with this reinforcement learning.